Hello. This is the last lecture of the semester. I am very happy, but still you have a few more homeworks to go. So please finish the homework as soon as possible, so that I can finish grading as soon as possible, so that we can enjoy the vacation. Let's review what we have done. Remember, we considered the linear regression model given by this form. Y, left-hand side variable y, is determined by another variable x according to this equation. Beta 0 is the intercept plus beta 1 times x plus an error term epsilon. Here I consider the example of cost and output, cost and quantity. So y is the total cost when you produce X amount of output. Then beta 0 can be interpreted as the fixed cost. So you have to pay beta 0 no matter how much you produce no matter how much you produce the output. And beta 1 is the marginal cost, because as you produce one more unit, your cost increases by beta 1. So exactly that's the definition of the marginal cost. And additionally, we allow an error term, which is literally a white noise. It's a noise. And in data, we cannot explain perfectly. So in that case, all the errors are included in epsilon. So, and from this linear regression model, and we had data. Oh, excuse me. Let's put it this way. So I made up imaginary data of amount of output and the total cost. So when you produce 2 units, your total cost is $15. And when you produce 9 units, your cost is 31. And so in that way, we have 12 observations and 12 pairs of observations. So in each pair, you have an output and its cost. And let's analyze that to use the data regression model. You can simply click data and data analysis. And you may go to regression here, and then just put the corresponding guys. Y is cost. What is explained by the model is the cost, and X, what explains the cost, is the output. Excuse me. Label, and I'm going to use linear fit plot. Okay, so when you click, you get this result. So the scatter plot shows the relationship. The blue dots are the observations. So the blue dots have increasing pattern, but it's a little bit up and down. There is a little bit of wiggles, and they are errors. So and going through those observations is the trend line. So the linear regression can be understood as to draw a trend line that fits those observations the best. So we are finding the best fitting line going through those observations. I'm going to explain how we can find the best line fit, or how we calculate that. But for a while, I'll just assume that it's given. And these are the outputs, the results. So you may want to look at these 3 tables. Especially the important part is here. These 2 guys are the most important numbers. So coefficient, the intercept term is 8.18, estimated to be 8.18, which is the fixed cost, estimate of fixed cost, and the the slope, the coefficient of the output is 2.38, which is the marginal cost, estimated marginal cost. And their respective standard error is reported here. So these two numbers are the most important estimation results. And let's see what we can do here. When you have cost and the marginal fixed cost and marginal cost estimates, they are cost function parameter estimates. Let me go back to where we stopped. So then you can predict the basic, the ultimate purpose of the regression model is to predict the cost given a certain number of outputs, certain amount of output. So for example, what we want to do here is I produce 10 units. I am going to produce 10 units. Then how much do I have to, how much does it cost? So that's to answer these kind of questions, we use the regression model and we estimated beta 0 and beta 1, right? Fixed cost and the marginal cost. And as the result, you choose X. You have to choose how much you produce in our example. And given a certain number of X, you can predict your Y. So this is the predicted value, which is usually referred to as the fitted value. So as I said, the line fit, the linear regression is fitting a line to the dots observations. So this observation is a point on the trend line, the regression line. So in our example, simply suppose that the fixed cost is estimated to be 8.2, so rounded at the first decimal place, and the marginal cost is estimated to be 2.38. Then what is the expectation of Y, expected value of Y, predicted value of Y when X, the output is 6.5? It is simple. Just put X is known, X is 6.5, and beta 0 and beta 1 are predicted to be these numbers. So just plug in beta 0, beta 1, X. Then you have these numbers, calculate this. When you calculate this, it is 23.67, right? That's so according to the model, when you produce 6.5 units, you are going to, it will cost you $23.67. So then what's good about this is it is particularly useful because X equals to 6.5 is not observed in our data. Let me go back. So in our observation, there is no output equals to 6.5. You have never produced that much, but still you can predict. It's kind of interpolation. Let me see. Here we are predicting this point 6.5, and it will be a point here. So when you connect, when not only you are connecting 6 and 7, so usually when you predict some Y at this point, you have a tendency to use the information right next to it, like 6 and 7. So you may take average between observation 6 and observation 7, but a better way is to use all possible observations between 1 and 9. So we use not only 2 observations, but 12 observations in this case. So you utilize more information, so it will be better. It's more likely to be a better estimate, better prediction at this point. So you draw a line across all the possible observations and then find the corresponding point. So this is exactly what I did. Same graph, basically same graph, and after you draw the trend line, then you can predict a point. At any point of X, you can find its predicted value. Say 2.5, then find this is the expected value, and at like 4.5 this point, and at 10 this point, right? The blue line, the regression line, the trend line, is the expected predicted output for each value of x. That's the definition, and that's how we set up the model. Okay, so then try this. What is the predicted value when you produce 5 units? The estimates are given here, so it should be super simple. I'm going to show you the answer in the next video. Thank you for watching this video.